Your eye is roughly spherical shaped. It's got 3 layers to it. The 3 layers are the outermost layer with the white layer, that's the sclera. You have a middle layer, which is the vascular layer, that's called the choroid layer. And then the innermost layer is the retina, or the nervous layer. This is where you find the photoreceptors. The clear front part of the sclera is called the cornea. It's clear and convex, meaning curved. In between that, you have the anterior chamber, which is filled with vitreous humor. You then have the lens. The function of the lens and the cornea is to bend or refract light. You also have the suspensory ligaments, which have a pigment to them. That's what makes your iris. The diameter of your iris, that's your pupil. So the cornea and the lens will refract the light back to this area in the back called the macula densa. Inside the macula densa is an indentation called the fovea centralis. This is where you will find rods, which are for black and white, and cones, which are for color vision. If the light hits those rods and cones, this will cause a chemical reaction, which will then generate an action potential. The action potential will travel down to the blind spot, which is your optic nerve. So those nerve impulses will go down the optic nerve to the primary visual center in the brain, and your brain will interpret that as a vision. So for the exam, know the 3 tunics. So sclera, choroid, retina. Know the cornea, anterior chamber, posterior chamber, lens, suspensory ligaments, macula densa, and fovea centralis. And then for hearing, so sound waves travel through the air. They are funneled in by the auricle or pinna, A-U-R-I-C-L-E, not Oracle like the computer company. They will get funneled in by the auricle or pinna, will travel down the external auditory canal or auditory meatus, and they will strike the tympanic membrane. The tympanic membrane will vibrate. That will then transfer those vibrations and magnify those vibrations by the malleus, incus, and stapes, hammer, anvil, and serpent. Make sure you use the Latin names, not the generic names. The stapes will punch like a piston into the vestibule of the inner ear. Then that will get transferred to a fluid wave, which will travel up the cochlea. At the base of the cochlea are short hairs. If those are waved, that sends an action potential for high pitch, and at the top is lower pitch. You then have the vestibular branches here. So these are the semicircular canals, and then you have the utricle and saccule. Inside of them is fluid and crystals. So if the crystals move, there's also a gelatinized cup in there. If those move, this is how our brain determines that there's motion. So we've got up and down, side to side, and rotation. Motion sickness occurs when there is conflicting sensory information coming in. So for example, if you were on like a cruise ship and you're in your cabin and you're kind of just staring at the wall and feeling the boat rocking, you're not actually moving and you're looking at a focal point on the wall. So your brain is being told by the sensors in your body and by your eyes that you're not moving, but your ears are sensing motion. So your brain freaks out because it's getting conflicting information, and that's what leads to motion sickness. How do we fix seasickness like that?
Patches.
You go, well, pitches, but what else do they tell you to do? Go out on deck and look at the horizon. That way you are getting, your eyes are seeing that yes, we're moving. Your body says yes, we're moving, and your ears say yes, we're moving. So that's what helps get rid of the motion sickness. Some of us, the crystals in the fluid moves more easily, so we're more prone to motion sickness. Some of us, they move less, so we are less prone to sickness. So that's why some people get motion sickness really easily. Some people hardly get motion sickness at all.